Okay, guys. Today what I'm going to do is I'm going to try to explain to you the equation that you love to hate. Here's the thing. You got to get your head around this. You just got to. And here's why. This little equation here, for the most part, is acid-base balance in the body. And you have to understand it to truly understand acid-base balance in the body. So let's review it, and then I'm going to show you a few things. All right? So look. CO2 is a byproduct of metabolism, right? It's what's left over after you break down glucose, fat, or amino acids to make ATP inside the cell. So CO2, when it's in excess, and where do you find CO2 in excess? You find it at the level of the cell and the systemic capillary, right? Because it's a byproduct of metabolism of the cells. So if there's high levels of CO2, they get dumped into the blood from the cell, it's going to force the equation to the right. Water should never limit a chemical reaction inside the cells of the body. If it does, you're in trouble. So when CO2 and water combine, they're going to form this stuff called carbonic acid. And carbonic acid then dissociates into free-floating hydrogen ions and bicarbonate ions. And any substance that forms free-floating hydrogen ions, by definition, is an acid. Therefore, CO2 is an acid. And if CO2 builds up, it will drop your pH. So when we talk about this, we got to talk about the balance between hydrogen ions, and bicarbonate ions. Bicarbonate is the primary base of the body. Hydrogen ions are produced primarily through metabolism. So the bodily fluids have to maintain a balance between free-floating hydrogen ions and bicarbonate. Otherwise, that's bad for you. You change your pH, enzymes that control all the chemical reactions inside your cell are temperature and pH sensitive. So if you alter the pH inside the cells and the blood, you will alter the shape of the enzymes and they won't be able to do their job, so you're in trouble. So let's look here. CO2 is an acid, right? We just talked about it, and is controlled by the respiratory system. Bicarbonate is a base, and it's primarily controlled by the kidneys. So the two systems that are involved in maintaining acid-base balance in the body are the respiratory system and the kidneys. The respiratory system controls carbon dioxide. I'll explain more in a little bit. Bicarbonate controls, the kidneys control bicarbonate. And this is important. The kidneys can compensate for any acid-base disturbance in the body if you live long enough. The problem is that it takes a while for them to compensate. So in the meantime, you wake up dead if your pH drops too low or goes too high. So with that understanding, one of the most important things that physicians will scream about is maintaining blood flow to the kidney. If somebody has very low blood pressure, they're in shock, the doctor will be screaming about maintaining blood flow to the kidney because they know that if you can keep the blood flow going to the kidneys, the kidney can correct any acid-base disturbance. Carbon dioxide, on the other hand, it's controlled by the respiratory system. And it happens much quicker than the kidneys. However, the respiratory system can't compensate forever, right? You can't be breathing 40 respirations per minute for your entire life. So what you do in the meantime is you struggle. So watch. CO2 is a major byproduct of the metabolism inside cells. Now watch, right? And we talked about this. Every living cell has a capillary that supplies that cell with what it needs. And arterial blood pumped by the left ventricle brings blood that is high in oxygen down to the cells of the body. And you need that oxygen to sit at the end of the electron transport chain, the mitochondria, right, in order to make ATP aerobically. But one of the byproducts of metabolism that the cell has to get rid of is carbon dioxide. Where's carbon dioxide highly concentrated? Inside the cell, because that's a byproduct of metabolism. So where are things going to go? Oxygen is going to move from high concentration in the arterial into the capillary into the cell. And CO2, which is highly concentrated in the cell and lowly concentrated in the blood, is going to move from the cell into the blood. It is that point that arterial blood becomes venous blood. So this blood, this venous blood, is now high in CO2. So at the level of the cell and the systemic capillary, the equation is going to move to the right, and you're going to form free-floating hydrogen ions. So the pH of venous blood compared to arterial blood, the pH of venous blood is more acidic than arterial blood because it contains more CO2. So you got this CO2 in the venous blood. Which way is the equation going to go? It's going to go towards the right. Why? Because you have more CO2. And this side of the equation, right, has to be equal to this side of the equation. So if you build up more CO2 at the level of the cell, like you're doing, that's going to form more hydrogen ions and bicarbonate ions. I hope you got that. So here's the other thing, right? Oh, please get this. All venous blood, all veins of the body dump their venous blood into the right side of the heart. All the venous blood from the right side of the heart gets pumped to the lungs. So watch. Who's watching? Here you got the circulation. You got the left side of the heart sends oxygenated blood to the cells of the body, right? Bam. Boom. So this right here, where you have capillaries and systemic capillaries in the cell, this is this picture, right? And where does all venous blood get dumped into? The right side of the heart. And where does the right side of the heart pump its blood? To the lungs. And you learned in general, I know you did, that the smallest vessel, blood vessel in the lung, is a pulmonary capillary, and every pulmonary capillary is associated with a one-cell thick membrane called an alveoli. So in this place, when we're talking about the lungs, this is this, right? Pulmonary capillary and alveoli. So what happens at the level of the cell? You're dumping CO2 into the blood. So because you're dumping CO2 into the blood, that's going to increase the amount of CO2. It's going to combine with water. It's going to form carbonic acid. And then the carbonic acid breaks down to hydrogen ions and bicarbonate ions. So you're increasing the amount of free-floating hydrogen ions at the level of the cell. So it's going to make the blood acidic. So your pH is going to drop potentially. But where does all that venous blood get dumped into? all the veins of the body dump their venous blood, watch it, into the right side of the heart. And the right side of the heart sends that blood to the lungs. What's the smallest blood vessel you got? A pulmonary capillary. What's associated with every pulmonary capillary? An alveoli. So in this case, you have the same equation here. But what do you do with the carbon dioxide that's in the pulmonary capillary? You get rid of it. It's highly concentrated in the pulmonary capillary, lowly concentrated in the alveoli. So you are removing carbon dioxide. Remember that this equation has to be balanced on this side and this side. So if you are removing carbon dioxide, what will happen is it will force the equation to the left. The hydrogen ion bicarbonate ion will combine to form carbonic acid, and that will dissociate into CO2 and water until the reactants on the left side are equal to the product on the right side. So reactants, product, either way, any way you look at it. So what's going to happen to the amount of free-floating hydrogen ions if they combine with the bicarbonate, get locked up in carbonic acid, and then dissociate into CO2 and water? The amount of free-floating hydrogen ions goes down, and therefore the pH goes up. So this is how the respiratory system controls carbon dioxide and therefore is intimately involved in maintaining the pH of the blood. And any system that is involved in maintaining the pH of the blood is referred to as a physiologic buffer. So the respiratory system is an example of a physiologic buffer, and how it works as a buffer is by controlling the levels of carbon dioxide. And CO2, ladies and gentlemen, is an acid. Okay, let's say for a minute that somebody takes a dirty sock and crams it down your throat, right? So if your airway is cut off, are you going to be able to get rid of carbon dioxide? Nope. So if you can't get rid of carbon dioxide because somebody stuck a dirty sock down your throat, CO2 is going to build up, and it's going to force the equation to the right. And you're going to build up more hydrogen ions. So what's going to happen to the pH of your blood? It's going to go down. What caused the problem? Well, you got a dirty sock down your throat and you can't breathe. So the respiratory system is struggling. So if we look, where are we looking? Here we're looking. Watch this. The kidneys control bicarbonate. I would write this down. What do the kidneys control? The kidneys control bicarbonate. And how they do that is the functional unit of the kidney is called the nephron. And what the kidney does is this. Bicarbonate is readily filtered by the glomerulus into the collecting tubules, so it can get peed out. Hydrogen ions, on the other hand, acid, cannot be filtered as easily. So what the kidney does, if there is a respiratory acidosis, you're building up CO2, right? Increased CO2 because you ain't breathing so good. the kidneys will reabsorb the bicarbonate back into the blood and then secrete the hydrogen ions to get rid of it. So let's look at this just a little bit more. And I use this, right? What system controls carbon dioxide? The lungs. What system controls bicarbonate? The kidneys, right? So let's say, for example, in our previous example that we just talked about, remember there has to be this balance, homeostasis, goal of the body, right? So let's say, for example, that your lungs ain't working so good. So your carbon dioxide goes up in the blood. In order to maintain the pH of the blood, what has to happen to your bicarbonate level? Well, if you look at this, your bicarbonate level is also going to have to go up to maintain that pH. So in the case of, I hope that's pretty close. It's almost balanced. In the case of a respiratory acidosis, right? You're building up carbon dioxide because somebody shoved a dirty rag down your throat. The only system that can compensate for a respiratory pH imbalance are the kidneys. So in the case of a respiratory acidosis where you are retaining CO2, the kidneys compensate by reabsorbing more bicarbonate back into the blood. And that's exactly what happens. So let's look at this for a minute. Now, one of the things that can happen in the body is, and remember, we talk about controlling hydrogen ions. If a cell, for whatever reason, and right now we don't need to know that, if the cell, for whatever reason, is making more hydrogen ions through metabolism, right? The chemical reactions that occur inside your cells, something's going on where the cells of your body are making more hydrogen ions than normal. They're going to get dumped into the blood. And if those hydrogen ions remain free floating, they will drop your pH, right? So watch. What's floating in your blood? A chemical that can help out? Our base bicarbonate, right? So bicarbonate is, by definition, it's a chemical, and it can prevent free-floating hydrogen ions from being free-floating. They can also let go of hydrogen ions so that they become free-floating if your pH goes up. So any chemical that can hold on to hydrogen ions or let go of hydrogen ions is by definition a buffer. And because it's a chemical, oh, cut it out, bicarbonate is an example of a chemical buffer. So watch, and this is the important thing. Let's say, for example, the amount of hydrogen ions in the blood goes up. If the amount of hydrogen ions in the blood goes up, watch it. Which way is the equation going to go? Right? So let's look. You have increased the amount of hydrogen ions. So because you've increased the amount of hydrogen ions, right, it has to force the equation to the left until this side of the equation and this side of the equation is equal. So if you build up hydrogen ions through metabolizing stuff inside your cells, it's going to force the equation this way. So what's the only system that can compensate for a metabolic acidosis? Right? You made hydrogen ions at the cell through metabolism. The only system that can compensate for a metabolic acidosis, because the equation is going this way, is your respiratory system. So the respiratory system controls carbon dioxide. So what's going to happen to the circulating level of free floating bicarbonate? Free floating bicarbonate. If the cells of the body are making more hydrogen ions through metabolism, you have a metabolic acidosis. What's going to happen to the circulating level of bicarbonate? It has, that circulating level of bicarbonate has to combine with the free-floating hydrogen ions to buffer it. So your circulating level of bicarbonate is going to go down. So how do you know you have a metabolic acidosis? Your bicarbonate levels in the blood drop. But what's the only system that can compensate, at least initially, for a metabolic acidosis? What controls carbon dioxide? The respiratory system. So let's look at our little equation here. So watch. Here you had an elevated CO2, right? The lungs weren't doing their job. In this case, because they were retaining CO2, you had a respiratory acidosis, right? CO2 is an acid. If you're retaining it, your pH is going to go down. So how did the kidneys help? The kidneys are the only system that can compensate for a respiratory pH disturbance. It compensated by reabsorbing more bicarbonate to help buffer those excess amount of free-floating hydrogen ions. Now, let's look at this. Let's look at it. I was looking. So, in this case, what you have is you have a situation where you are increasing the amount of hydrogen ions produced by the cells of the body. Who cares why? Right? So you have what's called a metabolic acidosis. You're making hydrogen ions free floating through metabolism. That's a metabolic acidosis. So if you produce more hydrogen ions at the level of the cell, what's floating in the blood? Bicarbonate, right? So bicarbonate has to buffer those things so that they don't drop your pH. So what's going to happen to the circulating level of bicarbonate if the amount of hydrogen ions produced by the cells goes up in the blood? It was here, right? What's going to happen is your bicarbonate level is going to drop. So now your bicarbonate level is here. Your CO2 level was here. You got to maintain that balance. What system controls carbon dioxide? The respiratory system, right? So if your bicarbonate level drops because you were making more hydrogen ions at the level of the cell, right? And then the hydrogen ions are combining to buffer them. In order to maintain the pH of the blood, what do you have to do with the amount of carbon dioxide in the blood? Well, you got to get rid of more carbon dioxide than normal in order to get that pH balanced. And what system controls carbon dioxide? The respiratory system. So in a metabolic acidosis, the only system that can compensate for a metabolic acidosis is the respiratory system. and you have to get rid of more CO2 than normal. So you will increase the rate at which you're breathing, right? Right? And you will increase the depth of breathing to try to get rid of more CO2 in an attempt to maintain that pH. So that explains which way the equation goes and why. Hope it helped.